In this video, I want to have a look at the future value of an annuity. So an annuity is defined as a financial plan that involves making periodical equal contributions into an account, and interest is compounded at the conclusion of each period. So that might be something like superannuation accounts or loan repayments. So if we look at the most basic examples of super accounts and loans, there's an equal contribution. The same amount of money is going into those, either being put into your super account or that you're paying off your loan each time period. Now, obviously, in reality, that might not happen exactly like that. You might decide to make extra contributions to your superannuation or pay off a little extra money on your loan in different time periods. But we're looking in this video just at the basic structure where every month or week or whatever time period is, you're making the same contribution. So in this video, I specifically want to look at calculating the future value of an annuity. So that's going to be its total value at the end of a time period. So that's the sum of all the contributions that have been made plus any interest that's been earned. Now, future values can be calculated using formulas, and that would get us exact values, assuming that everything stays constant, your contributions are always the same. But financial institutions and accountants and financial planners often use future value tables as a quick way to estimate future values. So those tables are rounded to 4 decimal places. So when you use that in your calculations, it's not going to be exact, but it's going to give us a pretty good idea of what that future value is going to be. So this here is an example of a future value table, and it's pulled from a past HSC paper. So the table shows the future value of a $1 annuity at different rates over different numbers of time periods. So this means that $1 is invested every time period. So say we're talking years, okay, so years and per annum for a minute. If we had an interest rate of 3% per annum and we were investing $1 every year for 7 years, that $1 at the end of 7 years, if it's at 3%, would now be worth $7.6625. So we need to make sure these interest rates and the time periods will work for any time period, whether it's days, weeks, months, whatever it is. But we need to make sure that our interest rate and our time periods are in the same units. So our first question for this table says a certain annuity involves making contributions of $4,000 into an account every 6 months for 3 years at an interest rate of 4% per annum. Part A asks us what is the future value of this annuity. So what we need to figure out is we need to get our 3 years and our 4% per annum. It's happening every 6 months, those contributions. So we need to calculate all this into the same time period. So if it's being contributed every 4 months, then our number of time periods it's happening every 6 months. For 3 years, our number of time periods will be twice per year. For 3 years would be 6. Our rate, if it's 4% per annum, but it's happening every 6 months, we need to halve that and we'd have 2%. So if we have a look in our table now, if we were to invest $1 every time period, so ignore our 4,000 for a minute, if we were to invest $1 every 6 months for 3 years at 4% per annum, we'd go down our 2% here until we got to 6, and we'd have this amount here. So that's the value, future value of $1. But we've got $4,000. So our future value of our annuity is going to be $4,000 times the future value of $1, which is that 6.3081. And if you pop that in your calculator, you'll end up with $25,232.40. Part B just asks us how much interest is earned. So part B. Now, this $25,232.40, that's the sum of all of our contributions plus any interest that was earned. So we want to go to figure out the interest, we're going to go this future value minus the sum of all our contributions. So our interest is going to be that $25,232.40 minus we invested $4,000 every 6 months for 3 years. So we invested $4,000 6 times. So if you pop all that in your calculator, and I've run out of room, but if you pop it all in, you should end up with $1,232.40. So that's the interest that was earned on that annuity. Question 2 is a little bit different. So instead of asking us for our future value, it's asking us for the contribution per period that would need to be made in order to get a certain future value. So part A asks us for a future value of $18,000 if the annuity earns 5% per annum for 6 years. So 5% per annum per 6 years would lead us to this 6.8019. So we would go 6.8019, 019 times our contribution, whatever our contribution was. And if we did that calculation, we want that to come out to give us that $18,000. This is for part A. So to figure out what that contribution is then, we're going to go our $18,000 divided by our 6.8019. And if you pop that in your calculator, you should end up with $2,646.32. Now we've rounded that to 2 decimal places because we're talking about money. So that means that we would need to contribute $2,646.32 at the end of each year in order to earn $18,000 under these conditions. All right, let's have a look at part B. So for part B, we've got an annuity earning 12% per annum, compounded quarterly for 2 years. So because it's 12% per annum, but it's compounded quarterly, we're going to have to go 12 divided by 4, which would get us 3% per quarter. And our 2 years, this is our N, our 2 years, but it's happening quarterly, so it's going to happen 4 times every year, means we're going to have a total of 8 time periods. So in this one, from our table, we're going to look at 3% and 8 time periods is going to be this value down here. So once we've got all that, it becomes the same working out as part A. So we're going to have 8.8923 times our contribution would give us our $8,500, which is the future value we're after. So then to find our contribution, we're going to have our $8,500 divided by that 8.8923, which will end up giving us $955.88. So we need to invest this much per quarter for 2 years to end up with a future value of $8,500. All right, so it's just a few examples of the future value of an annuity.